Let f minus half to 2 maps to r and g minus half to 2 maps to r be functions defined as fx equal to box of greatest integer of x square minus 3 and gx is also defined. Now if you see the first two options, that comprises one question, that is f is discontinuous at how many point in the domain, that we need to find out. Now what is fx? Fx is equal to greatest integer function of x square minus 3. We can take minus 3 out of the box function. Now the discontinuity will occur only due to the presence of box of x square. Whenever box of x square will be discontinuous, then and only then fx will be discontinuous, because this is a constant value. Now if you analyze, box of x square will be discontinuous within the domain. What is the domain? X belongs to closed interval minus half to 2. X belongs to minus half to 2. Within this domain, box x square will be discontinuous whenever x square takes integral value, except the situation when x square achieves a local minima. Right? In this way, very easily we can count the number of discontinuity. So this will be discontinuous whenever x square achieves integral value, that is x square is equal to integer, other than the cases where x square is an integer but the graph is achieving a local minima. Now if you see x square graph achieves local minima at x equal to 0. So x equal to 0 will be a point of continuity for this function, box x square. Okay, so let us count how many integral value x square can take. So within this domain, we can take x square can be 0, we are not taking. Next, x square can be 1, x square can be 2, x square can be 3, x square can be 4. That means corresponding x value within this domain will be 1, root 2, root 3 and 2. 2 is included here. So we have got 1, 2, 3, 4. 4 points of discontinuity. 4 points of discontinuity. 4 points of discontinuity of the function. So fx is discontinuous at 4 points within the domain. So option B is correct. And now if you concentrate on the other question, that is option C and D comprises one more question. That is gx is not differentiable at how many points? What is gx? Gx function is mod x plus mod 4x minus 7. Mod x plus mod 4x minus 7 into the common factor fx. So gx is equal to fx, which was box x square minus 3 into mod x plus mod 4x minus 7. This is the function. Now first of all, you see that due to the presence of this factor, the second factor is always continuous. Due to the presence of the first factor, jump discontinuity will appear wherever it is discontinuous, right? And here also the domain of the function is what? Domain of the function is open interval minus half to 2. X belongs to minus half to 2. Open interval minus half to 2. So at the end minus half and 2, we don't need to check for differentiability. We are checking for differentiability, right? So within the domain, whenever this function will show jump discontinuity, entire function will show jump discontinuity, right? What are the points? Those are the points 1, root 2, root 3. Okay. So due to the discontinuity of this function, entire function will be discontinuous. That means non-differentiable. So we got the point x equal to 1, root 2, root 3. So we got this 3 point first. These are non-differentiable point due to discontinuity. Clear? I am not taking 2 because 2 is open interval. Next, if we come to the situation that this function is not differentiable at which point? Mod x is not differentiable. Mod x is not differentiable at x equal to 0. And mod 4x minus 7 is not differentiable at x equal to 7 by 4. That is when 4x minus 7 is 0. Right? So mod x is not differentiable at x equal to 0. And this is differentiable at x equal to 0. So entire this product, this sum is not differentiable at x equal to 0. And this sum is also not differentiable at x equal to 7 by 4 because this is not differentiable at 7 by 4. So we got 2 more points, 0 and 7 by 4. So at 0, it will be non-differentiable. At 0, x equal to 0 will be one more non-differentiable points. But if you see x equal to 7 by 4, for 7 by 4, in the neighborhood of 7 by 4, what will happen to this factor? Box x square minus 3. As x tends to 7 by 4, you see box x square value is equal to, this is x is 7 by 4, so x square is 49 by 16. So it is 3 point something, 3.xx. So box x square value is 3. So box of x square minus 3 will be 0. So you can understand that in the neighborhood of 7 by 4, that is to the right and left of 7 by 4, this factor will be entirely 0. So that will make the entire function 0. So entire function 0 in the neighborhood of 7 by 4. So the graph will be totally along x-axis. The graph of the function will be totally on x-axis. So this is the graph. In the neighborhood of 7 by 4, the function is totally vanished, 0. So since it is 0, then it has a slope equal to 0. That means slope is defined. So at 7 by 4, the function is differentiable. So 7 by 4 point we are not going to consider for non-differentiability. So we have how many points we are getting? It is not differentiable at 1, root 2, root 3 and 0. So there are 4 points of not differentiability. So option C is correct.